Okay, let's dive right in. We're going to pull back the curtain on the unbelievably complex world of electronics manufacturing. For the companies that actually build the tech that powers our lives, we call them EMS factories. Production is this constant puzzle. You're always juggling speed, cost, and the need for absolute, perfect precision.
See, at the heart of every single device is a printed circuit board, a PCB. You can think of it like a tiny, dense city. The components are the buildings, and the little copper traces are the streets connecting everything. Putting this city together is a huge challenge, where even one tiny mistake can bring the whole thing crashing down.
So to solve this assembly puzzle, manufacturers have really relied on two main ways of getting all those components onto the board.
On one side, you've got surface mount technology, or SMT. This is the go-to for all the tiny, high-density parts that let us have such sleek, compact gadgets. And then, on the other side, there's through-hole technology, or THT. This is for parts with little wire leads that actually go through the board. It creates this incredibly strong physical connection, which is perfect for bigger parts or things like connectors that have to take some abuse.
Okay, but here's where things get tricky. While that SMT process is this beautiful, high-speed, automated dance, through-hole assembly, well, that's been a major headache for a long time, especially when you're dealing with components that are big, heavy, or just have a really weird shape.
And this quote really hits the nail on the head. When you have to rely on people to manually place and solder these tricky through-hole parts, you create a massive production bottleneck. I mean, think about it. Everyone works a little differently at a different speed. That leads directly to inconsistent quality, which is a total nightmare for any factory trying to run on a tight schedule.
So what does this actually mean for an EMS factory? Well, the consequences are immediate, and frankly, they're painful. Your labor costs shoot up, production slows way down, and the chance of a mistake and a faulty product goes through the roof. In today's market, you just can't grow your business or promise top-notch quality when a critical part of your process depends on manual work.
So how do you fix this? How do you break that bottleneck for good? Well, you've probably guessed it. You replace that repetitive, error-prone manual work with some seriously smart, purpose-built machines. The first big step in this revolution came from these automated insertion machines. They're designed specifically for all those standard through-hole parts, your everyday capacitors, resistors, and diodes. These machines can pick them, place them, and prep them with a speed and consistency that a human could never, ever match.
And to give you a sense of just how big a deal this is, some of these machines can place nearly 25,000 components an hour. Just let that sink in. And they do it with an error rate so low, less than 200 parts per million, that it completely rewrites the rules for quality and speed.
But that still leaves the biggest headache of all. What do you do about those really difficult parts? The big, clunky, custom-shaped components that we call odd forms. Well, this is where the newest automation is making a truly massive difference.
And this is where a whole new generation of automation comes into play. These machines are built from the ground up to handle those exact odd-form components that, until very recently, always needed a person's touch. This is what finally closes that automation gap.
Now, what's so cool about these new machines isn't just that they're fast, it's how they make this advanced tech totally accessible. First off, they're way cheaper. They're also so simple that an operator can get the hang of it in a single day. They're super versatile, so they can handle all sorts of different parts. And get this, they have quality control built right in.
And yet, they are insanely fast. Even with these weird, complicated, odd-form parts, we're talking about inserting up to 12,000 components an hour. This turns what used to be the slowest part of the line into another high-speed automated step.
One of the most clever features is something called active clenching. Here's how it works. After the machine pops a component through the board, a little mechanism underneath actually bends the metal leads. This physically locks the part in place so it can't move or fall out before it gets soldered. It's basically like having a tiny quality control expert working inside the machine itself.
And this diagram shows you exactly what's happening. On the left, you see the leads just poking through. But on the right, after clinching, they're bent and locked down. It's a simple idea, but it guarantees a perfect mechanical bond, which means you're all set for a flawless solder joint. It has a massive impact on quality.
So you have to understand, this isn't just about dropping one new machine onto the factory floor. This is a crucial building block for creating a truly smart, seamless, and integrated production line, from start to finish.
Imagine this. You can put these odd-form machines right in line with your other equipment. A board comes out of the SMT process, flows right into the odd-form machine for its through-hole parts, and then moves directly into an automated soldering system. You get this completely hands-free process that cuts down on handling, reduces the risk of damage, and just makes the whole factory way more efficient. So what's next? Well, if you look over the horizon, the next leap is already starting to happen. People are now developing AI systems that can teach robots how to do hyper-complex tasks that are still completely manual today. Things like carefully connecting all the delicate wire harnesses inside a car's dashboard.
And all of this leads us to the big question, right? As these incredible machines take over all the repetitive work, what's left for people to do? The answer is that our value doesn't disappear. It gets elevated. The future of manufacturing isn't about doing manual labor, it's about human creativity. It's about our ability to design, program, maintain, and innovate these amazing systems, shifting our focus from doing the work to creating the work itself.